Yes, good afternoon, all of you. So, all of you put your register number in chat box. Am I audible, right? Okay. Okay, within 5 minutes, sir will start the session. So, wait for 5 minutes.
Okay, good afternoon to all.
Yes, good afternoon, sir. Good afternoon, all. So, today we have a workshop on software engineering and delivered by Professor Basavaraj Honchali, sir. Sir has completed MTech and now Sir has pursuing PhD. So, now, sir, currently sir working in as a professor in KLE Engineering College, Chikkodi. Welcome you, sir.
Thank you.
So now
Thank
sir
you.
will start the session.
Okay. Yeah, good afternoon to all. Now let me present my screen.
No sir, your screen is not visible.
Yes, ma'am. I will share
Okay,
my
okay.
screen now. Is it visible, ma'am?
Yes, yes, sir.
Okay. Fine. Today we'll see about important concept, that is design model or designing the model from software engineering. As you all know, we are having so many software development or any development of any engineering field. If you're considering, each and every steps are having their own responsibilities to play. In that, design is also one of the part or one of the step But okay, without design, it is impossible to make the implementation. Or if implementation not happens, then testing also not happens properly. That is why design plays vital role here for building a very good design. We need to have good requirement also. Therefore, interaction between the end user as well as gathering of functional requirement as well as needed all kind of development requirements are playing vital role here. Therefore, design, it means what? The general term they have given here as a design, but design is nothing but a prototype. A design is a model that we can make use for the purpose of further implementation. Either it may be in the form of a prototype or it may be in the form of like any model. Okay, we are having in software engineering also in our field, computer science field also, we are having models like initially we are developing algorithms and then that can be converted into flowchart, DFT diagram, use case diagram. All these are then extended UML diagrams, class diagrams. These all are becoming design model, part of design model. Okay, that is totally design is a manifesto work. Design is a creativity. Creativity played by the engineering. Okay, for making the environment superior, for making the livelihood of any human being superior, along with other context. We need to have some good design. Any good software design plays or exhibits firmness. Firmness means a software should have that is a very less number of bugs. It means if bugs are present, then no one believes for using that software. Like that only commodity. A program should be suitable for the purpose of which it has been intended. Design must be specific. If design is not specific, then it becomes very difficult to understand that system also as well as for usage also. That is why we need to design a system for intended purpose, and that has to serve properly. Delight. It has to provide good interfaces. If interface is not proper, then it is becoming difficult for end user to use the functionalities provided for that functionalities provided by that software. Even though your design is very good, but if you are not provided good interfaces, then end users will not get that pleasantness. That is why these are the main three characteristics or the software design has to exhibit properly. This is the analysis model. As I told you, we are having several steps. In those steps, we are converting some of the models into another one model. Here, during the designing time of any of the software, initially the analyst will design different kind of diagrams or models. Those models are converted to design model. Like they have shown here at left side, analysis model. Scenario based elements like use case test, a text, use case diagrams, activity diagrams, all those diagrams they depict modular and that is modular structures of one completed design of a software or system. Flow oriented elements, data flow diagrams, control flow diagrams, process narratives. These flow oriented elements, they are going to show us, it means what? Whether properly the system has been built or not. Model has been built or not. That analyst will test that properly. It means what? after designing the after each and every modules, after designing them, what type of interaction happens between the modules, that will be checked, like properly data is flowing from one model to another model or not through DFD diagrams, DFD 0, 1, 2, 3, like that. DFD diagrams will be constructed and checked. Along with that, control flow is flowing properly from start to end or not of the system or not. Like that, it will be constructed and analyzed properly. Like that, only class based elements. It means abstract level of implementation has happened properly or not. Okay, like class, that is between the classes as well as after creation of objects, they are communicating properly or not, and then behaviors as well as data points are properly protected or not. All those things are being tested, and then their analysis model is converted to design model. Okay, analysis model is becoming reference, and on that reference, on that referred basis, a design model is constructed, like data class design, and then architectural design, interface design, and component level design. Like this, clearly they have separated into a hierarchical way. Design and quality. Of course, after designing by the design developed by the analyst, that must be tested properly, whether it is working or not properly or not. Efficiency will be tested, and its easiness will be tested, and whether it is providing complete behaviors or not. It means exhibiting properly according to the user requirements or not. All the things will be tested with respect to quality. There are 3 points they have considered here. The design must implement all of the explicit requirements. Okay, that is why during during the development time of a development cycle is containing a requirement phase. Okay, there a business analyst will collect all the requirements of end users. What are the requirements? Functional requirement as well as data requirements he is going to collect, and then he is preparing one document, a business requirement document. According to that, whether design has been made or not, all the functionalities, it is serving the customers or not. That will be checked. And then second point is the design must be a readable, understandable guide. Here by seeing that, it should feel easiness. It should not be complex. And as I told you, user interface must be clear. If it is, if user faces difficulty in usage, as well as the formatting of, it means data formats are not proper, patterns are not proper, development patterns, then it becomes difficult. It means quality decreases. The design should provide the complete picture of the software. It means this is the initial step. Design, we are not implementing here software. Design means we are creating the model. After creating that model, we are testing that for all the kind of data, functional and behavioral testing we are going to make on design. That is why whether it is providing complete data, functional as well as behavioral aspects of software or not, that will be tested. Then quality guidelines. During checking time of quality of a design, we have to consider these guidelines. A design should exhibit an architecture. Here that should have proper structure as well as that is inner some of the things that should not expose. That should not for viewers it should not look like a complex one. That has been created using recognizable architectural styles or patterns. It it is composed of components that exhibit good design characteristics that can be implemented in an evolutionary fashion. That is what I told you. Design is a fashion, or design is a creative work. There, we have to design. It is a incremental level as well as iterative level. The design goes. Whatever the changes or whatever the shortfalls are there in the previous version, that should be fulfilled in next version. Like that only. If any like front end or back end changes, we have to adapt for that. That we have to see, and we have to do the changes for current version. Like that, we have to go for architectural changes also properly. And then it should feel totally comfortable for the end user. A design should be modular. Yes, you all know about the difference between second generation languages as well as third generation languages, right? Here in second generation languages as well as the first generation language, there is no modular concept. There, each and every instructions are written linearly. But in third generation languages onwards, a function concept came into picture, as well as a object oriented concept came into picture. That onwards, a program can be felt as a set of modules. If each and every modules are independent, then it becomes very easy for understanding as well as debugging also. That is why the software should be logically partitioned into elements or subsystems. A design should contain distinct representation of data, architecture, interface, and components. A design should lead to data structure that are appropriate for the classes to be implemented and are drawn from recognizable data patterns. We have to see here repeatedly we are using term pattern. Pattern is nothing but that is linearly, that is these are the linear stepwise representations of usage of a system. Patterns we are calling. If each and every systems, if you are considering, they are having their own set of usages, that is a recurring patterns. Those appropriately, it means what, like each and every system, they are having their own style of representation of data. That is why during implementing time of designing time of any module, we have to see what type of data structure is appropriate for that, whether tree is appropriate or that is a stack, queue, what kind of data structure is appropriate for implementing, whether array is appropriate, that we have to see, and we have to go for implementing. A design should lead to components that exhibit independent functional characteristics. Yes, design should be modular, as I told you previously. That is why they should have the capacity of independently handle all its functionalities. The design should lead to interfaces that reduce the complexity. This is with respect to a user interface. User interface must be ease of use. It means it should not provide any complex navigation. It should have some ease of usage. A design should be derived using repeatable methods. Here, a design should have some components or libraries. Then, by using those libraries, why? Because if you are using libraries, then development time will get reduced. That is why some of the already constructed or already developed modules are there. Then we can reutilize and we can go for utilizing in our applications. A design should be represented using the notation that effectively communicates its meaning. Okay, it should be noted in proper manner. Like some of the systems, okay, depending on the application, yeah, if database application is there, which design we have to choose for that. If any like web development kind of design is there, what type of notation is suitable for that? That we have to check, and we have to use appropriate notations here during designing time. Design principles. These are the some of uh, principles which we have to follow during designing time of any software. The design process should not suffer from tunnel view. Okay, it means much of abstraction. The design should be traceable to the analysis model. The design should not reinvent the wheel. The design should minimize the intellectual distance between the software and the problem as it exists in the real world. The design should exhibit uniformity and integration. The design should be structured to accommodate changes. The design should be structured to degrade gently even when aberrant data and data events or operating conditions are encountered. Design is not coding. Coding is not design. The design should be assessed for quality as it is being created, not after the fact. The design should be reviewed to minimize conceptual errors. Okay, sorry for that. Actually, these are the aspects which we have to follow during design time. Okay, that is what they are saying. Okay, we have to design in a proper manner. Okay, we should not show only abstract view of that design. Okay, we have to show that is a completeness of the model that we have to show. Okay, inner built, okay, how that is there, and each and every navigations, how they are there, interfaces, how they are there. Yeah, all those. Only we should not show a tunnel vision. Okay, and then okay, we have to assess that model properly with respect to each and every functionalities. Fundamental concepts. That is, these are the fundamental concepts for designing. Abstraction. Okay, abstraction, it is during designing time of anything. As you all know, object-oriented design, that not allows easily accessing the data points for everyone. That protects, that abstracts. Okay, encapsulation is there, right? That is why we should not expose everything. It means inner built architecture, the overall structure of the software. Okay, patterns. Okay, conveys the essence. Okay, these are patterns are nothing but these are the some fixtures. Okay, like this only we have to develop. Like for example, if you are considering like during designing time of any like a mouse, if you are considering, then whatever the, it means whichever the company of company mouse, if you are considering, the design pattern, they are following step by step. It means what? First they have to prepare the base, and then they have to prepare the like a wheel and micro buttons, and then like that. It means what? During designing time of any software, like if you are considering your final year project only, some of the patterns are there. If you are following those patterns, then it becomes very easy for designing any kind of system. Patterns, I hope you understood. Like first step, what we have to do, second step, what we have to do. Like it is not hard. Like as I give you example of mouse. Okay, all companies mouse inner built is the same only. Okay, they are following same pattern, but here and there quality matters there. Okay, quality of materials, how they use, that matters, but pattern of development is same. Then separation of concerns. Okay, any complex problem can be more easily handled if it is subdivided into pieces. So that is what the divide and conquer approach we can apply here. Modularity, again the same thing here. If a system is divided into a number of modules, then we can handle with each and every modules properly, whether it means what, the development of that module, and what data it is required, what functionality it is exhibiting, whether it is properly doing or not. All that testing we can carry very easily with modularity, instead of carrying that with complex big model. Hiding, okay, some of the things we should not show, okay, some of the things we have to, okay, it means what, interfaces, okay, like okay, for example, administrative controls we should not provide for the end users. Okay, like if you are considering ATM machine, okay, whatever the functionalities which are required for end users, they are exposed. Okay, maintenance or okay, configuration, such kind of controls are kept hidden. And functional independence, okay, here functional independence, each and every module should have, okay, their own independent functions or okay, characteristics to okay, define themselves. Refinement, okay, refinement, okay, this is a step by step approach actually. Okay, here after designing a okay, first version, okay, that is tested properly, and if any refinements are required, then that can be done in next version. Okay, like that, refinements are required for improving the quality. And then aspects, okay, aspects, a mechanism for understanding how global requirement affects the design. Okay, refactoring, a recognition technique that is simplifies the design. Okay, refactoring, that is also same thing. Here refactoring, if any inner that is performance is degrading due to some modules, some of the modules, then we can redefine them, we can change them, and we can improve the collective performance of that system. Then object oriented design concepts, you all know about those, and we'll discuss in next subsequent class, and that is slides. Design classes provides design detail that will enable analysis classes to be implemented. Here, that is the what the abstraction again they have shown here. What is there inside the hull, that is hidden. Okay, only that is we can show the home, but inner whatever the how the inside, okay, that room is there, and whatever the components they are there, like light and some others, they are there, which are hidden, which are hidden by the door. Okay, only that is the required items we can show, like for example, if you are considering car, for rider of the car or users, end users of the car, they know only riding, but inner built, that is known by the mechanic only. Okay, like that, some of the things are hidden. Here also in computer science, data abstraction is required for protecting the information. Procedural abstraction, okay, only all the functions are not provided for all the users. Okay, here if you are considering banking application, there also all the functionalities of software are not provided for you, end users. Some of are given, some of the functionalities are there with respect to that is the banking people, some of the functionalities are there with respect to the end user. That is why, depending on that, if a role played by the end users, they are going to offer the accesses. Architecture. The overall architecture of the software and the way in which that software provides conceptual integrity of a system. Okay, totally. Architecture is nothing but, as you all know, in modularized design, okay, the modules are integrated and made into a system, complete system. But okay, internally, okay, each and every module, if they are exhibiting their work properly, then complete system will work properly. Okay, structural properties, okay, they have okay, structural properties. This aspect of the structural design representation defines the components of the system. It means like objects, filters, modules, and the manner in which those components are packed and interact with one another. Okay, how they are communicating with each other. Extra functional properties. The architectural design description should address how the design architecture achieves the requirements for performance, capacity, reliability, security, adaptability, and other system characteristics. Okay, these are the parameters of measuring how good the architecture is. Families of related systems. The architecture design should draw upon repeatable patterns that are commonly encountered in the design of families of similar systems. Okay, we need to follow during designing time of any system, we need to follow the patterns. Okay. Then pattern. What do you mean by pattern? Okay, you please remember pattern is nothing but that is a fixture. Okay, we have to follow. That is a procedure. That procedure we need to follow. Okay, as I told you during the designing time of any like monitor. Okay, all that. Okay, all the components which different companies are using. Okay, they all are same only. Okay, that is what the pattern of design is. Pattern name. Intent. Okay, also known as, it means what? Okay, that is a list of steps which are present in the okay, pattern, like a sequence of okay, like images or sequence of that is steps, or okay, we can say like that. Okay, pattern of development, you can say for that. Then motivation provides an example for the problem. Okay, capability, structure, participant, okay, collaborations, consequences, related patterns. Okay, these are the some of templates which we are using during designing time of the pattern. Okay, separation of concerns. Concern is a feature or behavior that is specified as part of the requirement model for the software. Okay, during development time of any complex problem, we have to show extra care, as well as we have to divide that complex problem into smaller problem, and then that piece of a problem can be solved, addressed, and then that can be that smaller piece of answers can be, or solutions can be mixed, and that aggregated solution is becoming solution for the complex problem. Like that, we need to take extra care during designing time of any complex problem. Modularity. Okay, modularity is a single attribute of software that allows a program to be intellectually manageable. Okay, here modularity plays vital role here. Okay, why? Because it reduces the complexity. Okay, some of the softwares, they are developed without dividing that into subsystems. It means modules. Those type of softwares we are calling as monolithic. It means we are monolithic software are the larger softwares which are developed without dividing that into smaller piece of modules. But modularity is required. Nowadays, how the complexity and the requirements of end users are very increasing, like that only. So the development of software systems are also becoming the complex. That is why we have to. It is easier to divide and develop according to the divided tasks. And during development time also, integrated development environments are providing modularized way of development only. Modularity. These are the modules. Here, how the number of modules they are going to increase. Likewise, cost of software also get increases. That is why, depending on the functionalities, how you a software design, how a software is providing. Likewise, modules are going to increase. Information hiding. That is what told you. Information hiding already we have discussed. Why information hiding is required? Reduce the likelihood of side effects. Okay. Then with respect to ATM machine, you can think about. Okay. Only required functionalities for the end users are provided. Then limits the global impact of local design decisions. Okay, that is like if you are thinking only about the local design, then some of the aspects which are happening, same type of software if somebody is designing, if that information hiding plays vital role here. Copying will not take place here if you are hiding. Emphasizes communication through controlled interfaces. Yes. Interface control is required. That is not allowed for anyone to use any of the functionalities. It means all those functionalities, the restriction is required. Discourages the use of global data. Discourages the use of global data. It means it is we can think in two ways actually. Discourages the use of global data. That is it is not allowed for anyone to access. That is for the security reason, and then during using time of that data, whether it is in concern with context or not, that also we have to think about. And then we have to make use of the data pattern lead to encapsulation. Yes, that is security is required for the data points. That is why encapsulation is required. That is also a way of hiding the information. That is abstraction. Results in high quality software, higher quality software. Yes, sometimes that is also considered because if that is for showing the results high quality, it means what? Some of the things are hidden. Stepwise refinement. During improving time of any of the software development, it will not happen all of suddenly. We have to first it means version wise we can go, like development happens as I told you in two ways, like incremental development or iterative development. In both the cases, depending on the feedback of end user, we can go for refining. Depending on the exhibition of its functionality, that is functionalities as well as its efficiency, we can go for improving its efficiency. by refining it. Therefore, it is a step by step process. All of suddenly it will not happen. Okay. First version, again refinement like that. It will become a good product at the end. Yeah, sizing modules. Here, sizing modules. That is a module. That's here some of the things inside architecturally, structurally they are hidden for each and every module. As well as if a module is very big, then it is becoming very difficult to understand also. Okay, therefore, that is what is there inside. It means what it is not a type of curiosity. It means what the inner design of that architecture of that module should be hidden. Okay, it is better to not show the development complexity here. Functional independence. Functional independence is achieved by developing modules with single-minded function and an aversion to excessive interaction with other modules. Independence, functional independence. Each and every modules they should have their own independence with their functionality. Okay, they should have this characteristic, a single-minded functionality. There are two things are there with respect to functional independence. One is cohesive and another one is coupling. Always we have to keep in our mind high cohesiveness must be present with respect to the development, and less coupling must be there with respect to any design. Here, if you are considering two modules, then that is cohesiveness. That is a line of codes are present here. Like they must be integrated within the. It means they have to have their strength within the module. It means integrity must be maintained within the module here. That is what cohesiveness we are calling. And then in concern with interaction between the modules, we are calling that as coupling. Cohesiveness is an indication of the relative functional strength of a module. A cohesive module performs a single task. It performs a single task. Then requires little interaction with other component. There are two things are there with respect to cohesiveness of each and every module. First, that has to that should be like single-minded. Therefore, they have shown given here. It does single task and it does very less interaction with the other components, other module. Then coupling is an indication of the relative interdependence among the modules. That does a communication with the other module and it does the necessity of its functionalities. Coupling depends on the interface complexity between the modules, the point at which entry or reference is made to the module, and what data pass across the interfaces. Aspect is a representation of cross-cutting concerns. Here, that is consider two requirements. That is like they have considered two requirements like A and B. Requirement A cross-cuts requirement of B. If a software decomposition has been chosen in which B cannot be satisfied without taking A into consideration. Okay, that is okay, that is aspect of okay, the software development. Okay, it is the modules, even though they are independent from one another, but all together, the design must be. It means each and every modules must be interdependent, and they together exhibit the work of the whole system aspects. Like consider to requirement for the safe home assured web application. Requirement A is described via the use case access camera surveillance via the internet. A design refinement would focus on those modules that would enable a registered user to access video from the camera placed throughout a space. Requirement B is a generic security requirement that states that a registered user must be validated prior to using. That is here surveillance system example they have given. If proper like authentication is there, then only they can open the system web app, and then they can observe the recorded things from the surveillance camera. It is good. It means that is the module that is present in the server and the camera all together, they are working, but that should be shown for who is having that authentication. Refactoring. Refactoring is the process of changing the software system in such a way that it does not alter the external behavior of the code, yet improves its internal structure. That is the refactoring. If that is performance of a system is not proper, it means not according to the requirement satisfactory. That time the modules or internal development in concern with any of the module should be refined. And after refining, again that will be tested with respect to its behavior or its efficiency. Whenever it is, as I told you, refactoring is nothing but it is a step-by-step process. It has to improve with its efficiency when certain changes that is been made with respect to any of the modules. When a software is refactored, the existing design is examined for redundancy, unused design elements, inefficient or unnecessary algorithms, poorly constructed or inappropriate data structures, or any other design failure that can be corrected to yield a better design. These are the characteristics. If they are there in any development, then we have to call that as a bad or inefficient system. Refactoring is required for overcoming from all these factors. Then object-oriented design concepts. Design classes. Design classes. Here, class is nothing but that is a blueprint of a system we are calling. That is not the real world entity, but a class is required for construction of real world entity. That is why classes are also considered as a design. They are going to show how the structure of one object is. That is why here there are three types of classes they have considered. One is the entity class, boundary class, controlled class. You may be knowing like entity class is essential essentially an object wrapped for the database table. Then a boundary class, it is a class used to model interaction between the systems surrounding and its inner working. Controller classes. Controller class is normally a class part of the model, like a model view control. Inheritance. That is what the main pillar of that object-oriented programming concept. Here, inheritance, that is the reusability as well as extendability takes place by using this inheritance only. Therefore, the modules, it is becoming very difficult to, sometimes it is becoming very difficult to design the things from scratch. If they are available already, then we can reuse them. Along with that, if any AD and that is already existing functionalities are there, we can go for building the new module by inheriting some of the characteristics which are there already with the parent class. Messages. Messages are also the components of object-oriented programming, which is used for communicating between the objects. It stimulates some behavior to occur in the receiving object. Polymorphism. Again, that is the thing. Polymorphism, a characteristic that greatly reduces the effort required to extend the design. By that, we can extend the code, reuse the code. Design classes. Analysis classes are refined during the design to become entity classes. Boundary classes are developed during the design to create the interfaces that the user sees and interacts with as the software is designed, as the software is used. Okay, controlled classes. As I told you, controller basically controls the flow of data. That is the one thing is there with respect to control class. This is the design module. This is similar to whatever the things they are there in the shown diagram that was there in the very beginning. That is represented in different angle. After the designing, all the analysis characteristics or functionalities, they are being covered in the design model or not, that can be mapped and tested. Model design elements. Data elements. Data elements, they have to fulfill the requirement, data requirement, the data model. In which manner, it means what type of data structure is appropriate for holding the data and what kind of data structure is suitable for the context of implementation that we have to see. And database architecture. Then structural elements, application domain, and then analysis class, their relationships, collaborations, and behaviors are transferred into design realization. Patterns and styles. These are some of the things we have to consider during architectural development. Interface elements, the user interface, external interfaces to other systems, devices, networks, or other procedures or consumers of information. Internal interfaces between various design components. These are the things we have to considered during the designing time of a graphical user interface or a front-end development. Okay, component elements. Okay, these component elements are nothing but they are the interfaces which are used for connecting the multiple modules. Deployment elements. Then architectural elements. The architectural model is derived from three sources. Information about the application domain for the software to be built. Specific requirements model elements such as data flow diagrams or analysis classes, their relationships and collaborations for the problem at hand. The availability of architectural patterns and styles. These are the some of the things we have to consider during development time of any architectural model. Interface model. This shows that is a keypad. If that is a phone which is there with the keypad that they have shown. That is mobile phone. That is keypad, and then it means what? The keypad, which is becoming main interface between the that is if you are considering any laptop or mobile phone, any of the personal data, digital assistants, if you are considering. That is it is nothing but like earlier like a joystick or key buttons you can consider. And if you are going for like it is one example they have given with respect to these devices like mobile phone. Keypad is required for interacting with the functionalities provided by the mobile phone. Okay, like that only. If you are considering the desktop, keypad, desktop or laptop, if you are considering, that is the keypad is the primary source of navigation. Okay, that is required. And some of the models are command based. Some of the models are they are graphical user interface used. Like that. Before that, it is a command user interface only. Component elements. Component elements. These are the like this is a module. Sensor module. You can say like it is like a Arduino board or a Raspberry Pi. For that sensor is connected. How interaction takes place between the sensor module and sensor management, or you can say a tiny operating system. How data transfer takes place. It means after sensing the data, how it transfers and how it gets additional signals. That is all the interfaces provided for the between the modules. Deployment. Yes, these are the like how internally each and every modules are being kept together and how they are interacting with each other. That is all matters with respect to the quality as well as its efficiency. Deployment must be proper. These are the some of things which we learned with respect to the design. You see the actually design patterns. Okay, as I told you, design pattern or pattern based design. Okay, here, okay, development of most of the, okay, like if you are considering, okay, one example I shown you, I told you with respect to monitor as well as mouse. Like that only if you are considering, okay, the mobile phone, or okay, even if you are considering a pen, okay, the design pattern is almost same for all the companies pen. Is it right or not? Like okay, all are okay, outer jacket and internal ink filled refill, and then it is having to open. It means what a pattern of design. I hope you are understanding. With respect to software also, instead of going for implementing from the scratch, if readily available, some of the designs are, if they are already available, then we can reutilize them. Okay, like that only, you can understand like this also. Instead of going on thinking independently, like during designing time of one car, instead of thinking going starting thinking in our own way, we can follow some of the already invented design models, right? We can study the design models which are been already there in the market. We can check what is the pattern. It means what, first at what first step what we have to follow, second step what we have to go for, third step what we have to go for, like this. Already the constructed, it means procedure is available. That procedure we can take and we can adopt in our implementation or design, and we have to design that system according to the already provided or already existing procedure. Okay, design patterns are already available, but some of the things we have to change there. Why? Because during designing time of any system, we should not copy each and everything, right? Our existingness is also required. Okay, therefore for reference as well as for implementation of, it means what, improvement of a system can be done by using pattern based design, definitely. Okay, that is what they have given here. Design patterns can speed up the development process by providing the tested prone development paradigms. Okay, already existing procedures we can adopt and we can go for designing the system. Okay, here each of us has encountered a design problem and slightly thought, I wonder if anyone has developed a solution to for this. Okay, it means what, one question they have asked here, like instead of going from scratch, you can that is query, or you can search for the solution. If that solution is required or already implemented, then we can think over that solution whether it is appropriate or not. If that is appropriate for our solution also, appropriate for our design also, then adopt it. If any slight changes are required, change that much only. Instead of thinking from scratch, it is better to search for solution already designed by somebody. Design pattern. These are codified method for describing problems, and their solution allows the software engineering community to capture design knowledge in a way that enables it to be reused. Okay. Reusability. Each pattern describes a problem that occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use the solution a million times over without ever doing it the same way twice. Okay, already existing solutions we can utilize, and we can go for improving the things. A three-part rule, a rule which expresses a relation between a certain context, problem, and situation. Solution. Okay, here, say it is a three-part they have given here, like a context, problem, and solution. Okay, if you want to improve the efficiency of a design, first existing solution we need to search for. If any solution is already available, that solution, whether it is applicable for our context or not, that we have to think whether it is according to our problem statement or not, that we have to think, and then how much suitable that solution for our context, that we have to think. If that is allowed to do the changes for that existing solution, that much, it means what? According to our context and problem, we need to modify and we need to apply that. Basic concepts. The context. Context allows the reader to understand the environment in which the problem resides and what solution might be appropriate within that environment. Okay, context study is required here. Okay, what is that is my test bed, that we have to think about. Okay, it means what is in which it means hardware, software requirements, and then that is what is my area planned. Okay, all those things we need to study first, and then go for searching the patterns. Okay, once that pattern is available, then you cross check whether it is suitable for the developing context or not. Okay, if that is suitable, then we can utilize that, or else we can go for changing that. Okay, it means search for another one pattern, design pattern. A set of requirements, including limitations and constraints, acts as a system of force that influences how the problem can be interpreted within its context and how the solution can be effectively applied. Effective pattern. According to Copeland, he characterizes an effective design pattern in the following way. It solves a problem. Okay, it means a pattern should be efficient for solving the problem. Patterns capture solutions, not just abstract principles or strategies. That has to solve the problem completely, and then it is a Brown concept. Patterns capture solutions with a track record, not theories or speculations. It means that theoretically or blindly we should not apply that. The solution is not obvious. Many problem solving techniques try to derive solutions from first principle. The best pattern generate a solution to a problem indirectly, a necessary approach for the most difficult problems of design. A solution is not obvious. We have to apply it first. If that is suitable, it is well and good, or else we have to go for modifying it. It describes a relationship. Patterns does not just describe modules, but describe deeper system structures and mechanisms. The pattern has a significant human component. It means some part of human that is comfort or quality of life it expects. Generative patterns. These are the patterns which generally they are going to provide the solution. Generative pattern, these are the patterns. It is the first pattern, a solution to a problem in a context. In earlier days of patterns, we used the term generative to mean creational. It means what? This is generally one the patterns are described here. Generative patterns describe an important and repeatable aspects of the system, and then provide us with a way to build that aspect within the system of force that are unique to a given context. A collection of generative design patterns could be used to generate an application or computer-based system whose architecture enables it to adapt to changes. Kind of patterns. Patterns are of different kind of. Architectural patterns describe broad-based design problems that are solved using the structural approach. Data patterns describe recurring data-oriented problems and the data modeling solutions that can be used to solve the problems. Here, appropriate data structure, we need to make use component patterns. These are addressing the problems associated with the development of subsystems and components, the manner in which they communicate with one another, and their placement within a large architecture. Interface design pattern describes common user interface problems and their solution with a system of forces that includes the specific characteristics of end users. And web app patterns, they are addressing a problem set that is encountered when building web apps and often incorporates many of the other patterns categorized just mentioned. It means what? Depending on the what type of application we are carrying or designing here, that type of patterns we have to make use. Okay. Yeah. These are the overall pattern-based design. They are there in the syllabus. Okay. Yeah, with this, I am concluding my topic. And yeah, if you are having any questions to ask or something, you can ask me.
Yes, if you're having any questions, sir, please share your video.
Yeah, video. Shall I share?
Yes, sir.
Okay. Okay.
Yes, if you're having any questions, please put in chat box. I think though they don't have any questions, sir.
Yes.
Okay.
Fine.
Sir, can you on your camera?
Yes, sir.
Okay, sir. Okay, thank you, sir. So
Yeah,
the
thank
session was a wonderful one. So I think some of them are left due to some network issue.
No, actually, ma'am, a number of people, they are very less. Okay, that
Yes,
is
sir.
what the concern is. Okay, why? Because if strength is more, then we also get some kind of zeal as well as energy to talk, actually.
Yes,
That
sir.
is what the thing.
Okay, sir. Thank you, sir. So the session was good, sir.
Okay, thank you.
Okay, sir.
Thank you.